Hi Pre-Calc students, welcome to our first flipped classroom lesson on polar coordinates. I think you'll enjoy this chapter because there's a lot of fun things we can do, a lot of neat projects and cool designs that we can make. So here we go. You can take some notes as we follow along with these slides. As you can see on this slide, most of you are really familiar with the Cartesian coordinate system. That's your typical X and Y axis. And of course, when we have points on there, it's just determined by an X coordinate and a Y coordinate. Now, when we get to the polar coordinate system, this is a whole new ball game. Consists of, you can see a point O called the pole, half axis starting at O and pointing to the right known as the polar axis. So really it's just like an x-axis going to the right. But instead of an x and a y, we have two other features, r and theta, as you can see by the highlighted stuff there. R is the distance of that point from the origin, and then theta is the angle from that positive x-axis, the pole as they call it, and the point. Keep in mind we're just describing points here and just an alternative way to state what they are. Okay, next slide, if I can get to it here, is going to actually show you what a polar grid looks like. And as we see, it's just going to look like a circle basically, and should be coming up here momentarily. Yeah, there it is. So there's our polar axis, the pole as you can see, and just a bunch of concentric looking circles as we call it here. But the R value will be the distance from this origin to the point, and then theta is that angle, and that'll actually swing you around and allow us to graph all kinds of various points there. The next slide will help us see what the effect of that R value has on the actual poles here. This is a little slide, kind of a cool thing with this TI Inspire calculator. Just allows you to see some animation kind of right on screen here as that comes up. We'll have some polar grid paper for you in class that you can use to graph these things. So as you watch me move this slider, you can see the effect of the length of that axis there. It should increase or decrease. Notice that this R value can be either positive or negative as we slide that back and forth. As you can see, I'm having a little bit of a hard time with the slider here, but as it goes back and forth, you can see There we go. So now you can see how this is affected here. Here's r equals 0, and my claw here is going kind of crazy. So you can see it's positive as it goes down toward the third quadrant there. But I can slide it back up this way, and I can make it negative, and you can see how that affects the r value. Okay. Now, the next slide will show us that we can have several points on this coordinate system. We can name them in several different ways. So in other words, a point in this coordinate system is not unique. We can contrast that with our normal Cartesian coordinate system, where if you have a point like 3, -5, that's it. There's no other way to name that point. But in the polar coordinate system, we can actually name a point in several ways. Here we go. Sorry about that. So we'll see this better in class perhaps, but you can kind of trace this out. They say here the point, or I say the point 3 pi over 3, which is 360 degrees. That would be in the first quadrant. That would also be the exact same point with these 3 other coordinates that are listed here. We'll show you how that works in class. How do you get a point that has the same radius but a different angle? You can kind of pause your device and write down a conjecture right now, and then I'll answer it on the next slide. The r value is the same, but you can change theta. So for example, we have a couple points here that I listed: 6 pi over 3, 6 pi over 4. They have the same r value. In other words, the length of that line would be the same, but the angle would be different. Okay, how do you find the angle that will graph the same point if the radius has the opposite sign of the original point? We'll talk about this in the next slide. You could kind of pause and write down a little conjecture at this point. So think of the radius as pointing in the opposite direction as the angle if you're going to change it. So if I have the point 3, 120, and the point -3, -60 are really the same point. If you think of that point, A is in the second quadrant, 120 degrees is in the second quadrant, and the r value of 3 pointing in that direction. So that's clearly going to be in the second quadrant. Now point B, -60 degrees, if you think about that with our circle chart, that will drop you down into the fourth quadrant. But since r equals -3, instead of going toward the fourth quadrant, it actually goes in reverse, and it's plotted in the opposite direction in quadrant 2. Now you could try some of these next ones here, see if you could figure out 3 other polar coordinates for each of those following. Again, this is just once around the circle chart, can you come up with 3 other polar coordinates for those? We'll talk about these much more in class as well. Here's kind of a general idea about how to do that. If you have a particular polar coordinate, remember polar coordinates are always 2 features, the r and the theta. You could represent them in this fashion. So by adding multiples of 2 pi, you'll get to the same spot. Change the sign of the radius and add pi, then add multiples of 2 pi. That's kind of confusing. Usually we'll just kind of reason it out a little bit. We'll show you how that works more in class. Next we're going to take a look at a couple of equations. that can be produced. We'll look at several polar equations over the course of this chapter, but some of the real basic ones will be just r equals something and theta equals something. And so we will get to that here in the next slide as soon as it pops up here. Eventually in this chapter we'll be doing quite a bit of conversions. We'll always be trying to convert between the new stuff, this polar coordinates that we're not used to, and the rectangular coordinates which we are used to. So here's the basic one of r. Remember, r is kind of like the radius. You can think of it as that. And so if you have an equation of r equaling some number, of course it will produce a circle. The one that's pictured here, r equals 3. That, of course, is a circle with radius 3. And then in like fashion, we can do the same thing with theta. Now, we can't really show this on the graphing calculator, but if you picture this, an equation might be theta equals some angle. And if you picture that this angle, any r value could be along this angle, an r value that's positive or negative. So really what's going to be produced here is a straight line. We'll look at this in class as well. So thus ends our first little mini lecture on the flipped curriculum here that we're going to try, and hopefully you made it through this and are able to see what this looks like. As soon as the next slide comes up, I have a special treat for those of you who made it through this. Notice it says the first 5 people that tell me what I want for Christmas will receive a special candy treat. So here it is. You have to listen carefully. What I want for Christmas is a pair of microwavable hand warmers. Microwavable hand warmers. Thanks, and we'll see you in class tomorrow.